you're all masters on StreamYard and conferencing and community. So you probably have your game together. Okay, we're live. 11, 12 seconds. So yeah, we'll be streaming this in different communities in Vietnam, the Android Cafe in the Droid from Vietnam group, the GDE group. So I'll send you later also some metrics on how many people we're reaching. But with that said, well, Kayla, Huyen, thank you very much for coming to our event. And Javin, once more with the Vietnamese community. Just some introduction about you. Huyen is a GD in Kotlin and Android. She's based in the United States, in Colorado, if I'm right, and working for Trello / Atlassian. And Kayla is based in Singapore, Kotlin and Android GD as well, or
only Kotlin.
Kotlin GD. Yeah, working for Zuhlke, Swiss-based company or Switzerland-based company with offices in Singapore, in Vietnam as well, right? And I know that you're doing some hiring, so if anybody's interested, please ping Kayla anytime. And yeah, so it's our first event of the Lunar New Year 2022, and in fact of the Gregorian calendar as well. So it's going to be online since the situation in Vietnam is still evolving very positively, but it's still evolving. With that said, I hope that next time we can greet you in person. Who knows, maybe at the Droid from Vietnam or any other event. And yeah, Huyen will be talking about Compose, if I'm correct. And your session will be the first one. Thank you so much, by the way, for waking up early. We know that in Colorado it's quite early at the moment.
No worries. Very happy to be here.
So yeah, Huyen, the stage is all yours. Let us know if you need anything. You can see that if there is anything people might be writing on Facebook, and you'll be able to see here any chat from or any message from anybody. Feel free to take any question live if you feel like that, or otherwise we can do it at the end of the event.
Yeah, I'll probably do things mostly. I'm going to be focusing on taking questions at the end. If I do see it, I probably will take questions. But I think if I am not answering, it's not because I'm ignoring. I'm just I get a little focused, a little overly focused. So I appreciate it.
Makes sense. So yeah, the stage is all yours. Thank you so much, Huyen. And
yeah.
Up to you.
So I'm going to be actually doing this series easiest with two. Okay. Let me see if I can share this screen. Is my screen visible? My desktop visible from here?
No, I think it needs to come on the here on the back side of things, but I can't see yet your.
Okay, let me try this again. Screen one. Okay. Chrome has lost permission to. I'm so sorry. Let me. Okay.
Maybe you need to give permissions and reconnect. Right?
Yeah, I'll do that real quick. Screen recording. Okay, well, that's interesting. Okay. Sorry.
I think it's happening lately also when you update the version of Chrome that some of those permissions need to be given again.
That has definitely happened to me. Google, where's Google Chrome? Let me do that. Okay. Oh, I might have to reconnect. I'm so sorry. I'll be right back.
Yeah, no worries. Back here.
I'm back. Sorry about that. Let me try this one more time. Okay. Is that? I think I can see my actual screen there. So perfect. All right. All right. Okay. Let me get there here. Okay. All right. So I just wanted to say, I guess right off the bat, let me get a little more organized here. Rất vui được làm quen với tất cả các bạn. I'm actually mẹ bố đến từ Hà Nội, but I'm completely born and raised in America, so my Vietnamese is terrible, but I'm really, really proud and happy to be here to talk to you about the future of animations. So hopefully if you're an Android developer, you've gotten to work with Jetpack Compose a little bit. And I'm really excited about animations in Compose for a number of different reasons, but I think before we kind of really get into some code and some examples, I really wanted to talk about maybe if you haven't gotten a chance to expose yourself to the new Jetpack Compose animation APIs, talk about why they're kind of awesome and how they might be a big departure from what you've traditionally done for Android. So let me see this running. Yeah, there we go. So how are Jetpack Compose animations different from traditional view-based animations? So kind of the easiest thing is Kotlin. Kotlin's very different. Not that you can't use Kotlin with animation views today, but the entire Compose animation API, like the rest of Compose, is built completely with Kotlin. And what's really interesting is that the low-level APIs that drive most animations are backed by coroutines. So if you find coroutines hard like I do, some of those low-level APIs might be an interesting and new experience. And the way that you style and structure animation code in your Android application is a little bit different. If you've been working with Jetpack Compose, what's interesting is that a lot of animations are composable based. So they kind of live within the composition itself. And some animations are extension functions, kind of like factory methods or other kind of customizers and additional kind of behaviors can be added as more like extension functions, kind of with the rest of the Jetpack Compose APIs. And I'll show that later too. But just overall, you can see the influence of Kotlin as like a base language with really nice, fluent, easy to read APIs and little tiny DSLs here and there. And it's kind of really interesting to see also the influence of, the modern architectures as well, with the idea of Compose, React-like, UDF type architectures. Obviously, Compose animations being in Jetpack Compose, they need to work with composition. And it's a little bit different. There are things that will be quite different from the traditional view with the measure, layout, draw type cycle. And you'll see sometimes maybe when you write animations, you have to think about it a little differently, but hopefully a little bit easier in places. And, it's really interesting because, and I think Nick Butcher, who is a wonderful developer advocate at Google, mentioned how difficult it can be doing animation, which is at its very core just taking a value and interpolating it from one start value to a target value. And that process is inherently stateful, right? You have to hold on to that value that you're animating. But, in this modern architecture world, we generally try to make views as stateless as possible. And so there's a little bit of an interesting conflict there, right? Where you have state, you have state that you must reflect with animations, but we have this kind of increasingly for like a better way of saying it, dumb views, views that just simply reflect some object, some state, rather than being very complex themselves. So there's a lot of really interesting kind of architectural things that you can see, very modern style development in the APIs. And, the animation APIs are totally greenfield. It's a clean slate. That's a good thing and a bad thing in cases, mostly a good thing. If you've been doing Android UI work for a long time, you know that animations can be really confusing. That's because Android's about 10 years old. And in that 10 years, we've gone from Android 1, simple Android views to now with Android 12 to 13. And we've have, material and motion design and all these more complex, more modern concepts and patterns still built on the old Android view system. And I think to make up for it and to kind of grow the UI with the times, the Android team has added over the years different Android APIs, but there's a lot of them. There's the old Android animation system or view animation system. There's property animators and value animators. There's physics-based animation. There's motion layout. There's just all kinds of things. And knowing when to use them and how to use them and which is the best, situation to use each one is really difficult. You don't have that anymore with Jetpack Compose. There's one animation system. And it's really interesting because you can see all of the lessons, all of the good patterns, all of the good practices from 10 years of doing animation on Android, and you can see them in the API. They inform, the defaults, they inform how, you customize animation. So it's really cool to see compose animations being just like the rest of compose, kind of like a nice wiping of the slate and kind of restart. And hopefully animations are a lot easier than they used to be. So let's go ahead. I wanted to hop into both code and examples, and I'm actually going to move this over here. So I wrote an app that will basically just be kind of like the basis for all my examples in my code. And we'll start with the low-level APIs. And let me see if I can pull it out there. I guess that's about as big as I can make it. So let's start really low level, because I think that's the easiest place to kind of compare Android view animations with compose animations. Because really, Jetpack Compose is so different from doing traditional Android layouts that it's hard to compare them as you get kind of higher and higher level. But I have 2 clocks. They're being drawn on canvases. And if you're someone like me who's done a lot of custom views in their time or just likes canvas drawing, if we go over here on the left, you can kind of see, okay, there's some very familiar code, drawing lines, drawing circles, and we're animating them, right? And I mentioned that animation at its core is just interpolation of one value from a start to a target. And so the values I'm interpolating here is angles. And there's actually 2 animations going on for each clock. There's an animation for the minute hand and an animation for the second hand, although they're moving a lot faster than that for the purposes of the demo. And I'm interpolating the angle of each hand from 0 to 360 to go all the way around. And yeah, that's what I'm doing here in this code. But the animation part comes in here. We can see that the value of that degree, that value of that animation is drawn here from these animators. And looking back, we can see that, okay, here's a value animator. Hopefully lots of you have had to, well, I mean, it's actually one of my favorite of the Android View APIs. So I'm always happy to see them. But this is kind of like, the low level little engines, the documentation calls them, that drive a lot of Android animations. And, we have this little factory method here where we're creating a very specific animator that has a start value and an end value. I think you can actually have intermediate values as well. And that's basically the animator's job, is to take you from that start value to that end value. And there's other settings that we can do, like the duration, how long the animation is, interpolation, basically between the start and end, how fast, how that rate of change might move, which kind of makes the animation look a little bit differently, feel a little bit differently. Sometimes you can refer to it easing. And so the important parts of hooking this animator into our UI come next. So every time that value changes, we get what is known as a frame. Just think exactly like the frames of a video. And here we have an update listener, so that every time that animator has said, okay, I've changed my value, it is able to call a callback and you can do some things with it. In this case, since I'm trying to animate and I'm doing a custom view, I'm tapping into that draw cycle where, okay, so my value has changed. What I'm going to do on the update is invalidate, which basically says to the view, hey, you need to redraw. And now with that new degree value that I have, I'll end up back down here where I have the updated degree value. I'll draw again with the hands in a slightly different place, and then repeating that cycle over and over as the animator continues to kind of tick along between our start and end values. And we have to start the animation. This is just declaring the object, so we have to call start. And I'm calling start rather immediately. So this is still in the view initialization stage. So basically, as soon as the view is created, I'm starting the clock. So that's kind of just what I wanted to do. I wanted to say, hey, the view is visible. Let's start the clock, like very literally and figuratively. So that's the view-based one. So let's take a look real quick at I can split my screen. Yeah. We'll take a look at the compose-based one right here. Okay, if I go down, or I rather go up here. So just as a side note, the Compose Canvas API is very similar, but it's actually been has some really great ergonomics added to it. So that's a really great thing to look forward to. But generally speaking, it's rather the same. I have my function down here where I've kind of abstracted some stuff and done some fancy local Kotlin things, because why not? But in the end, really what matters is that I'm pulling some animated value and using it to draw my 2 clock hands. Now, if I go over here and look at where these values come from, you can see it's quite different. This is the animatable, not the animator, the animatable. And this is one of the lowest level APIs that you'll find in Jetpack Compose animations. And it's very similar to Animator in that it's this little engine, and it kind of just drives a value from where it is currently to an end value. So that's already kind of a difference, where Animator kind of had a very set start and end value. Animatables are kind of more flexible. They have a current value. And then what you do is, rather than having it set when you declare the animatable, if we go down here, we can see that there's this method called animate to. And basically animate to kind of steers that animatable to a new target value. And kind of looking more kind of broadly back, you can see, well, I don't have an update listener. I don't have a start method. How is this working? So what's super interesting is that everything I'm going to talk about for this example and for other examples is really based on the idea of Jetpack Compose and compositions, layouts, and views, really just responding to state changes. So if you've done, much Jetpack Compose yet, this will look very familiar, where at some point there will be some state somewhere. Maybe it comes from some RX or flow stream, maybe like live data. And what you really want to do in your Jetpack Compose compositions is to just have visual, like the UI, respond to changes in some state object, some immutable object that you want to just render that object. And occasionally we'll have these things like state. And these values here, the UI, or the composition rather, can just kind of watch them. And whenever something happens, it can update parts of the composition that use that value. So here I have these two animatables. They're using the remember function so that, throughout the different cycles of composition and recomposition, these values will be remembered and can be used as state here. And if I go down back to where I started them, rather than having the update listener where we're very explicitly saying, okay, the value's updated, I'm going to redraw. The value's updated, I'm going to redraw. We really just turn these two values into state. And just by using Jetpack Compose as is, the composition will just know, okay, the animatable just changed, redraw. The animatable is changed, recompose, really, in this world. And that's what Animate 2 can help you do. So as I mentioned before, these are all backed by coroutines. So this launched effect is a composable, and it actually launches a coroutine within the scope of the current composition, and it'll execute this block. So what's happening here is launched effect will run this block where I have animate to in right on initial composition. So launched effect, and this is really neat to me when I figured out how to do this. It took me a while, but launched effect has several parameters that you can pass to it called keys. And again, what happens is it looks at the keys, and anytime one of them have changed, then it reruns the block. It relaunches the coroutine that it's given below. And I've given it unit.
And yes, one comment. Do you think we could make the font maybe a little bit bigger?
Yeah, bigger. Yeah, sure. I'm so sorry. I should have
that's
asked.
amazing.
That's good? Okay.
Let us know if you can see that, but yeah, I think now looks good.
Sorry about that. Hopefully you can be more. I'll try to keep it wider now. Oop, go back here. Let me know. I'm so sorry. I was trying to watch chat. So where was I? Right. So launched effect takes that block and then launches a coroutine. And what's happening here is that I've passed it unit, which is a constant value. So this will only ever get run when initial composition happens. So I'm kind of emulating what I did before with my view, where I kind of started it after I initialized it. And that's what I'm doing here. And a couple other things that are neat about Animate 2 is that, again, rather than having a set start and end, it's just kind of steering that animation. And in terms of coroutine speak, Animate 2 actually, if it's called successively, will cancel the previous job that was animating the value and restart it. And what you get kind of in the end, if you call Animate 2, successively, is actually a continuous stream of animation values. If you're trying to kind of re-steer like a value animator, you couldn't do that. You'd have to stop it, you'd restart it, you create a new value animator with two different start and stops, and it's just a lot more code. But now in Jetpack Compose animation world, we just call a method and it takes the work away from us of having to steer, which I think is really awesome. And again, is trying to tap into this whole concept and this whole like driving motivation of using state and just relying on state changes and having Compose do the work of propagating them to your composition, which I think is really cool. So this is really, really low level. You really shouldn't be in this low level of an API normally day to day. Obviously, if you're doing canvas drawing, you're probably going to be using animatables. But something that's really great about Jetpack Compose is how it kind of takes, again, lessons from the past and it turns them into this bright and shiny new API. And I think it's not just that it takes, previous patterns, good defaults, but it also takes commonly appearing problems and, patterns that we have to do and makes them super easy. So what's something that we do a lot with animations? Well, we show and hide things. And here in my example app, I have a simple crab picture and it's showing and hiding. And I'm able to do that with Jetpack Compose in response to this switch toggling back and forth. So sorry, I'm just going to clean up my desk so I can see chat just in case. But if I go to where that code lives, here is that animated visibility construct. And so this is where we see an animation API that's actually composable. So this lives in the hierarchy of your layout. And I think this is super neat as kind of like a concept, because if you think about the way we usually do views, animation in views, you have your layout usually in some XML file. And very, very, very often, or almost all the time, your animation code lives somewhere else. It might be a transition that's in another XML file. It might be Java or Kotlin code that lives, in your activity or some other class, but they're really separate, right? There's like a disconnect. And so if you look at a layout in a traditional like Android layout, you may not necessarily know it's animating. And vice versa, if you look at animation code, you might not know the context of other views in that layout. But here with animated visibility, it's this composable is wrapping the content that animates. So you can tell exactly what parts of this layout will be shown and hidden. And you can see kind of the context around it, which I think is just really cool because it's this really nice blend that Jetpack composes in general of layout and the logic, the code, the things that make the layout interesting, that feed data into it, that make it, conditionally render a certain way or another. And I think that's really cool. So the way this animated visibility works is again on state. So up here, zoom in a little more, because I know my screen's huge, is this shown variable. And just like we had before, we have some mutable state, which is a Boolean value, some Boolean state, and we're having it be remembered throughout composition. And this variable is piped into animated visibility. And so a lot of these Android animate or these Jetpack Compose animation APIs have usually one parameter where you can feed in some state into it. And so basically, as that state changes kind of above, Compose will do the work of basically kind of sending that updated value into this composable. And so that's what this visible parameter is. It's a parameter that receives hopefully some changing state, and then animated visibility does the work of moving it around for you. So if we look at my animation, it's okay. This is default. This is what happens out of the box. And I kind of find it a little funny because my image is kind of going up into the controls. What if I wanted it to kind of live at the bottom, kind of below my screen, and move up and down so that it kind of is like sliding in and out, kind of almost like a bottom sheet? How would I do that? So what I'm going to do is I'm actually going to cheat a little bit. I'm going to comment out this composable, and I'm going to go down here and use this. What? Oh, I think I missed one. Live coding. I missed a bracket. There it is. Okay. So here, I'm going to uncomment out this version. And if you can see here, I've got a different animated visibility, and it's got a little more stuff in it. What we have here is, instead of just having the state in there, I've added two parameters. So when I show and hide something, we can say that the content enters and the content exits. And there's going to be some transition that happens on each. So in order to tell Compose, hey, I want my image to slide in and also kind of fade in when it enters the screen, I literally put slide in and plus, oops, excitedly clicking, and fade in. Like I'm almost literally adding these two animations together, which I think is really cool. And then for exit, I do something very similar. I say, hey, compose, vertically slide out my image and plus fade it out. And I just love that. That's using that Kotlin like operator overloading syntax to make this kind of a really neat and really, fluent kind of animation specification. And what's even cooler is I kind of mentioned like DSLs. There's actually a keyframe DSL. So keyframes, if you're not as familiar with like doing Flash animation or After Effects and things like that, keyframes is basically this idea that within my animation, I'm going to pick certain points in that kind of time period where I really want the value of the interpolated value to be a specific thing. It's kind of almost like gradients and like breakpoints and gradients even, but I want the value to be something particular at a particular time. And so here what I'm saying is, okay, overall, the animation is half a second, 500 milliseconds long, but I want the alpha for this to be 0 at 150 milliseconds. And I absolutely adore this. This is using Kotlin Infix to create this cute little operator, more or less. And I just think this is another great example of how the Android team, the Jetpack Compose team, has tried to make the user experience, but in this case, the user is us, a little bit nicer and a little bit easier. And I love the idea of doing something so complex like for keyframes, but doing it in like 2 lines of code. I just think that's amazing. So, Enrique, how much longer do I have in terms of time?
Pretty much as much as you want. So we normally have something like between 30-40 minutes. It's 26.
Okay.
We started a couple of minutes late, so take your time.
All right, sure. Thank you. I just want to make sure I didn't like eat up all the time. Awesome. So another common thing that you might try to do with animations is get content to fit, or at least I know that's something that I've done often on teams. Like say we might have a text box and we might have this kind of like, background here, this blue-green thing kind of background. And we want it to basically wrap whatever content that is. I feel like there's been so many times where we've either downloaded resizable text view or had to write it on our own, depending on the part in our app. And you can see here that with this written in Compose, I'm clicking next and the content is changing. And not only is this box, the background around it wrapping, but it also has a slight animation. It's a bit quick, but there's animation there. Now, thinking about how I would do this in, Android View world, I'm sure there's going to be lots of text measuring. There's going to be like measuring and layout passes that I'd have to write. In Jetpack Compose, for this, I have one line of code. So if you've worked with Jetpack Compose, you might have seen modifiers. Modifiers are this kind of catch-all for things that can change the behavior, change the styling, add decorations to a composable. That's like literally it. Pretty much every composable that comes in Jetpack Compose has this modifier parameter, and like layout parameters live there now, padding lives there now, text colors, a lot of different things live in these modifiers. And what I think is kind of cool is that now we have this animate content size modifier, which it used to be experimental until 1.1. I think now it's like stable. And what's really cool is that this is just another modifier. And so what's happening here is that I have this text box and it does fill the width, but I've left the height rather to wrap content. And what happens is then I say, okay, animate the content size, as an additional behavior. And since I've kind of left the content to, left the height rather, to wrap content, it will now just say, okay, well, you asked me to animate when the content size changes. So as this changes height, Jetpack Composer is animating it for me. And I think that's really cool. And of course, you may find that, the animation is not quite the way you want it. You might want to change it up, but you can see there's already just so many great things, a very decent animation available out of the box. And I keep talking about these defaults, right? So I wanted to kind of go in and see what these default parameters look like. I'll zoom in a little more. And so when you want to customize an animation, very often you'll see this animation spec named parameter. And there's some class called finite animation spec, animation specification. Now for this, and for a lot of other animations, I lost the thing. There's this method that's being called spring. And if we look inside of it, there's this damping ratio, there's stiffness. This is a spring, like literally like a physics spring. And I totally left my slides behind, but I'm going to catch up. So if you're thinking about like physics springs, what you might think of is, or be reminded of rather, is the physics-based animation Android API. And I always think about this example of a little Android, and as you drag down, it kind of, pulls the spring out. And if you let go, it actually, the Android kind of like pulls back. And this is all, physics-based, spring physics rather. And I remember, I don't know if you're like me, when I saw this, I was like, oh, that's really cool. When would I use this? I don't really have a physics, oriented application. I have just a regular application with like drag and drop and all that kind of stuff. Why would I use this? So it's really interesting that in the last few years, if you look at some of the talks by, again, like Nick Butcher, who's a developer advocate, and also Doris Liu, who is the engineer who's actually working on Jetpack Compose APIs. A few years ago, when they were still just mostly talking about Android views, they actually started recommending using the physics-based animations for just regular old animation views and for translations. So here's a simple circle that's being dragged, and it actually has a spring applied to it. And the reason that they say that, and I definitely recommend, just for at least a high level, even if you're all Jetpack Compose now, I would definitely listen to Nick's talk, because what he says is that, when things change direction in real life, when they move, it's not like, on a screen where if I say, okay, box, go in the other direction, it can, turn immediately and then go in the other direction. Things in real life have momentum, they have weight. And the Google recommendation is to use, if you can, the physics-based spring type animations to bring some of this momentum and some of this kind of tactileness to, the interactions in your app. And as you can see from the default, that's what they really want you to do. And I think this is, again, going back to what I mentioned about, good defaults and good patterns being kind of just part of the out of the box, rather, Jetpack Compose animations. So I just wanted to also show you, so also just to compare what it's like. So far, everything I've shown in Jetpack Compose has been me saying, oh, look how concise and look how nicely this is, nicely kind of written this is in Compose. And just to kind of hammer the point home, I have a little icon here, a little monku kind of like bouncing around the screen. It's actually using code that Nick gave with his talk to, again, I mean, this is kind of a silly example. You really won't, I probably wouldn't use this in my app. I'm not sure why you would have an icon bouncing around, but there you go. To kind of hammer the point home about how cleanly the new APIs have been designed. If I open up the view that I used to implement this little bouncing icon, this is all the code that I need. There's like, what is this? 50 lines of code, 40 lines of code. And, it's not the best. I mean, it's sort of readable, but it's just a lot. It is boilerplate. And if we just go back to, this default, you can just put this, you can just call spring, the spring function yourself, and have the same thing in, like 30 times less code. And so I just think that's really awesome. And I think it's also something that the animation APIs are empowering us to do more complex, more delightful things a lot easier, a lot more cleanly, and with a lot less code. And imagine me writing that 30 lines of code for like 3, 4, or 5 different elements in my screen. It's kind of amazing, again, the change in ergonomics for animation APIs. So when I was learning Jetpack Compose animation APIs, I think the thing that I saw the most, like for example, the API I saw the most was animate something as state. And animate as state is kind of like, I think, a good building block if you're experimenting with Jetpack Compose animations to kind of build animations off of. So I have here an image and I have 2 toggles. And as I change the toggles, or if I flip the toggles back and forth, I'm changing the saturation of the image. So I'm changing it from full color to black and white. And I'm also changing the size from these are 2 hard-coded max and min sizes. And I'm basically using these animate something as state to make this happen. And to show you how that looks, it looks a little, actually, that's the actual class. Where's my example? Here it is. So if I go down here, so the thing that I think was a big kind of hurdle for me to kind of get over with just Jetpack Compose in general, and also with animations, is just thinking about everything as state. And making sure that, I write APIs that are just going to be, as flat, as dumb as possible, and that are just going to take in some value and display that value. And so to kind of work backwards, I have here a color filter that is on this image that is displaying this image, and I have width, and it's keyed into this width value up here. And then similarly for, the color filter, there's some saturation that it takes in to make it black and white or full color. And then I have a value that it's kind of watching and listening to make that happen. So I have here animate DP state, animate float state. There's probably an animate into state and a few other kind of something as state. And basically what these different methods are kind of ways of wrapping that animatable that we did earlier and giving it a nicer kind of like abstraction. And again, it's all about steering some value, a float value, a DP value to some target. And, as that value is being steered, those changes are being fed just from using Jetpack Compose from these values down to, my image here. And so what animate DP state, animate float state are doing are creating those little, engines, those little animation engines. And so there's a target value that is what the animation is driving towards. And then I have my animation spec here where I can kind of customize it and make it move and look how I exactly want. And what's interesting here is if you look, the target value is what's driving the image changes, right? Now, what is going to be driving and basically triggering these animations is more state. So if I go all the way up here, this is the kind of container that wraps around my animation example. And I have is black and white and is full size. These are two Boolean states that respond to these switches. And so as these two Boolean values change, that goes into, this animate float state and this animate DP state, these two composables, and it drives the change in those. So whenever there's a change in the Boolean state, it says, okay, I need to reset the target value, and then that animation gets steered, and then that steering, that kind of moving from the current value to the new value is piped into the image. So you can kind of see again how we're stacking state with state with state. And before we probably have like half a dozen update listeners and all kinds of things going on. But here we can just structure it very logically and connect a UI component to a flag, that flag to some animators, and that animators to this image. And again, I just think it's really cool, the building blocks and the new way of thinking about kind of building these interactions, and about how really these kind of animated states can live side by side with other state, more like database state in your app. And it's all kind of this more unified way of looking at both layout and animations. So I want to cruise through just the last few examples. I just want to talk about some of the more advanced APIs. So my entire app is based on this composable called animated content. And animated content is basically a way for you to coordinate like the swapping of like larger pieces of content within your app. And I'll just show it rather than keep explaining it. So my app here is a really simple kind of, list to detail view. I have a list view, and then when I click in, I have a detail view sliding in. And this is all done with this composable, and I'll make that a little bigger, called animated content. So animated content is a composable, and its job is to allow you to, number one, render some content, some composition based on state, but also, allow you to specify how that content transitions in and out. So you're always going to have some, current content. And as the state that it's listening to changes, you're going to have new content coming in, and that old content needs to leave. And so it allows you to specify not just the content itself, but how the switching between content happens. And so if we go down here, it's like any other composable where, you kind of have the parent tag, and then you have the content inside. And here, target example is, sorry to go back, swing around a lot, but here is my target state. So it's my parameter that is basically defining what animated content is listening to and going to be responding to changes in. And if I go down here, this is that value, that target state. I basically made an enum class that basically says, okay, I have a low-level API example, and so on and so forth. and also a none state. And what is going on in this content block is that, okay, there's this example value. This is the state of this kind of composition. And I can basically tell, I can tell Jetpack Compose what to render based on that state. So if my target example is not equal to none, which basically is me saying, okay, I have selected an example. It's kind of a backwards way of saying it and a little confusing, but basically I'm saying, okay, if you have some example selected, then render that content. Otherwise, we're going to be on this list screen and just render that. So that's me specifying the content that corresponds to a specific state. And then the really fun part is being able to use this transition spec, this transition specification, to describe how those changes between these different states happen. And so I'm again kind of utilizing the state as, a conditional for how I want things to change. So if my target state is not equal to none, or if I've selected an example, I'm going to slide in that new content. So the new content is going to slide in, and with that enter transition, I'm going to fade out the old stuff. And so basically the return type of this transition spec is going to be this content transform. And this with operator is actually an infix function, is basically pairing an enter transition with an exit transition. So it's defining how the new content comes in and how the old content comes out. And if we scroll down here, my other option other than doing this is, okay, I'm going back to my main screen, back to this list right here. And so I'm going to fade in the content, the entering content, and slide out the exiting content. And again, using Kotlin to create a nice API, making it fairly simple and straightforward to kind of, describe an entire behavior in a very simple way. And so that's animated content. All right, so I'm going to blast through my last example, which I keep backing out of by going back to animated content. Wait, it's right here. So I kind of cheated and I hid this. As I click this toggle, I am hiding something, but I'm actually doing a lot. So what I'm doing, and it's hard to see just because I picked really bad animations, is that I have a card here. There's some elevation. I'm actually lowering that elevation, and I'm also changing the alpha of this canvas in here. And if I go to where it is, what we haven't talked about yet is how to group a bunch of children together. So if you're used to doing animation in Android views, you might have be using stuff with animator sets, as a way of coordinating animations between different children. So what's interesting is say animated visibility, it's working on kind of a subsection of the composition tree, but it's hard for me to kind of say have a sibling kind of child somewhere else kind of included in that. And one way to do that, one way to coordinate different animations is to use update transition. So update transition here is a composable. It keys off a state just like everything else. So it takes its target state, and what update transition does is just shares this state among different child animations. So here I have some extension methods like animate float, animate DP. They look a lot like animate float estate, animate DP estate, but rather than being their own little composable that kind of specifically say, hey, this animate float estate here is listening to the state up there, it's just sharing. It's because it's part of this transition here. It's just going to share listening in on this target state. And so here's an addition of a child animation. Here's another addition. And if we go down here, we can even add a more complex animation like this animated visibility composable also to this transition. And because animated visibility, needs state to drive it, which is this visible parameter. This is why I don't like using it because it's kind of hard to see what it is, but this it is actually still this target state. And so this animation is also kind of sharing the same state. And by doing that, I can go ahead and whenever that switch toggles, do these 3 or 4 animations that aren't exactly in the same set of children, but that are kind of next to each other and coordinate them. I can go up here and see that there's other things I can do. I can, of course, do a transition spec and kind of customize things a bit. And yeah, it's kind of just, as you can see, rather than having 18 different APIs that all kind of do different things, we just have this one API that kind of builds on each other, that kind of uses the same style and naming and kind of a coherent idea of what you're doing when you animate this and animate that, and being able to kind of compose them, chain them together, and do really complex things with the basic building blocks. So just to wrap up, I know way over time. I just wanted to wrap up with some just thoughts. They're fun. Jetpack Compose animations are really fun. And if you are doing Jetpack Compose for yourself, for work, I would definitely dive into animations. I know like animations are total pain in the butt and have been for many years, but I think this new API represents a really good chance to make them not intimidating. And as we're kind of in this modern world of Android and app development, you need to be delightful. You need to kind of create really beautiful, polished experiences. And now you can do that just so much easier with animations, with the Jetpack Compose animation APIs. A few caveats, of course, it is based on coroutines. So if you're low level and you're confused by coroutines like me, that would be a challenge. This is still an API that's being built. That's a work in progress. You might find things that are experimental, or that new APIs are coming in and changing. So it's just going to happen. And there are things that are not quite in there. If you're looking for something that's more like motion layout, which choreographs things, which is kind of more user input driven animations, that's not in yet, though I hear it's going to be. But yeah, I would just really recommend anyone doing Jetpack Compose to totally start playing around with animations and see what you can do. So that's my time. Thank you very, very much, Sin Kaman, for and also thank you, Enrique, and the rest of the organizers for having me. I'm really happy to be here and to talk about one of my favorite subjects. So.
Thank you so much, Huyen, for being with the Vietnamese community and teaching us about compose and animations. If any of you folks have any question for Huyen before she starts working, because it's like 7:46 in Colorado right now, huh?
It's actually 6:46.
Oh, wow, okay. Much earlier than I expected. Sorry for that.
No worries, no worries. I'm really energized, so it's really fun. Thank you.
Okay, let's see if we get any questions. So maybe in the meantime, is there any companion library that includes animations that we can use with Compose, or give us any set of default animations similar to this Accompanies library that we?
Yeah. In terms of like kind of like out of the box animations, I'm not sure. I'm sure there's someone working on it. I know actually, if you follow Alex Lockwood from Lyft, he's been doing some really interesting stuff, although more low level drawings. I'm actually not aware of any kind of like user, just because I am not aware. I'm sure someone's working on one where people have written stuff out of the box. I feel like I actually saw one in the last one, but I don't remember. But yeah, I think people are still working on them. These are pretty new APIs, so I'm just personally not aware, but I think people are definitely doing some really interesting stuff with it. I know I kind of just thought when you asked that question of accompanist right away, but I think there's a lot of room to do like good animation libraries, because the building blocks are here to build really much more elaborate things. Yeah, it's been really tempting sometimes for me as well at work. Although I'm always building code that's like really specific to Trello. But yeah, I don't know yet. But if there aren't already, I'm sure there will be some really soon. Hopefully.
Yeah, it's part of the success of the ecosystem, right? Having those libraries that we can use and extend our little universe of whatever framework we're using.
Yeah. I think it's just really interesting. Actually, last year, so this is last year, so maybe that's kind of a cheating thing. But I know, I think Leland Richardson was talking, was being interviewed for a conference, and I think people were asking, him, hey, what about this composable, or can you add this composable? And it's sort of a frustrating answer, but I think he really encouraged people to do things on their own and make their own composables. And that really, I guess it's very much kind of a Google approach, is where they give you very basic tools, more or less. They try to cover bases, but especially with Compose, I think they're trying to leave it to us developers to really kind of build the more complex or intricate things like usual, but hopefully it's a little bit easier now with these APIs.
Yeah, at least it's stable, right? And not changing as it was doing before, where the API completely breaks from version to version.
Actually, now is a really good time to work with Compose animations, because actually a lot of the code that I was playing around with before was all experimental, had experimental tags everywhere. But now a lot of them have stabilized. So I think it's a lot safer to use some of these APIs like animated content about like, I mean, before 1.1 it was experimental. So, but now it wasn't. So I got to take all those tags out of my code. So that was great.
So you see, folks, if you jump into Compose now, you will get rid of a lot of annotations. That's always good. Mental health. We have here a question from Fogni. How is the interoperability for combining animations from motion layout, Compose, and the programmatic ones?
It's okay. I haven't experimented extensively, but at my work, we have been, using Android views, within our Compose hierarchies for a little bit now. I'd say like it's fine, but it's not. I think true interoperability is not quite the same because again, like the old APIs work specifically with Android views. So I will say like if you have complex animation code that lives in your kind of old Android views, it'll continue to work fine even in a Compose hierarchy. At least that's what we've seen. But kind of having the code live side by side hasn't really worked for us too much because it's hard to reach in to Android views very cleanly, and we've had to do some really weird stuff. We have like a large app. It's old. It has a lot of I won't say spaghetti code, but it has a lot of complex interconnections, and there's a bit of a gap between Android view code talking to Compose code. There's just very particular points where it communicates. So actually having the animation code kind of like blend more seamlessly is hard. But if you have some animation code already inside an Android view, it works as far as we've seen. I know that's not like the best answer, but if you had it before, it won't break. But it's hard kind of coordinating them in a nice way, if that answers your question.
Yeah, certainly. Nam Luong Swang have now another question. Do you think Jetpack Compose can completely replace XML?
I mean, that's kind of my goal. And I say this as someone who was, I think when Jetpack Compose was first announced, I was really skeptical. And I've lived for, 10 years with XML. And I kind of always thought it was a really good separation of concerns with your layout over here and your architecture, your activity, all that other stuff here. Now that I work with Compose, I totally think that if you have a chance to write a project entirely in Compose, you should do it. Especially for new projects, I think it's totally fine to leave XML behind and to work with Compose because it is the future. I'm sure, I don't know when, but at some point XML will be deprecated. And I think that Compose is it's just got so much stuff. It's just so much cleaner. I would just say, yeah, you can, if you start a new project today, don't worry about XML layouts, just do it in Compose.
Okay, folks, we might have time for one more question. So if any of you wants to check anything with Huyen, as they say on the weddings, say it now. Or, well, in this case, you don't need to wait forever. They can probably reach out to you in, what's, by the way, the best way to...
I'm so sorry. Let me share my screen real quick. So just to have it on the screen, but you can follow me on Twitter or on Instagram. My handle is quite long. It's Queen Code Monkey. And my site is randomlytyping.com. I should have had that up the whole time, but yeah, I'm usually pretty available on Twitter, and I'm always happy to answer questions, especially about animations. I mean, about Android and Kotlin in general, but animations are kind of my fun thing right now. So
great. So, folks, if you want to ping Huyen, remember to use Twitter. I think for the Vietnamese community, Twitter is not the first social network, but actually, I think many of them have it especially for development purposes and people in tech and stuff. Great. So, Huyen, thank you so much for sharing your time with us. It's pretty early in Colorado, so we're double thankful for that. And we hope to welcome you in Saigon or Hanoi in the future at some point when things get back to normal.
I would absolutely love that. Thank you so much, Enrique, and thanks you for having me. I'm really, really proud and happy to be here. And it's been a rough year. I've had to cancel on Enrique a couple of times, so I really appreciate you asking me again because I'm so thrilled to be here. So thank you.
Absolutely, I'll keep asking as we organize more events. So
definitely. So, thank you.
Nice. Then our next speaker, Kayla. It's gonna be now starting her session. You might have met Kayla, some of us you were actually in the last Direct on Vietnam, as mentioned. I think you've been in Vietnam a few more times. And Yeah, so up to you now. I think if you can share your screen, I'll be able to incorporate it into the our stream.
Yep. Thank you, Enrique.
So in Singapore, it's now 1 more hour than Saigon, right? If I'm correct. 21:54, a bit late for you. It's hard to coordinate those things, right? Like if you like to put people or put them to work together in Europe, the US, and Asia, sometimes you really need to make like very creative with the times you're proposing.
Yeah, sorry, I need to rejoin again
Yeah,
to
no
give
worries.
some permissions. Yeah, sorry.
Over here. Hi, Kayla. Can you say something? Yeah. Okay.
Yeah, right. Screen.
So you'll need to click on the share button, and then your screen should appear here on the backstage, and then I should be able to add it.
Yeah, I am doing that.
Okay.
Right. Great. Thank you.
Yeah. Okay, so yeah, Kayla will be speaking about Kotlin and refactoring. So again, thank you so much, and the stage is all yours.
Thank you. Thank you, Enrique, for this opportunity. And thank you, all of you who joined this Thursday evening after work. So I will try to be quick as possible. So today I'll be talking about Kotlin and some refactoring sharings. And a few years back, I just realized Kotlin and I get fall in love with it. And I spent some time to migrate a Java application to Kotlin. So today I will be sharing some little bit sharings at what I have learned after that. So if we talk about myself, I'm Kyrmyzy right now. I'm working in Zuhlke engineering company, and we have opened new brand new office in Ho Chi Minh place, and we're hiring. Find out me in LinkedIn or any other social networks. We'll be happy to refer. So okay. And just now Huyen was talking about the compose, and it looks great, and this is a great library, great APIs, and I had the chance to work with it like in a previous project, but unfortunately not all the projects are using the latest API or like latest MVVM architectures or anything else. So that's why for some projects still I need to use refactoring. I need to find out the ways how I can still like do some updates in Kotlin and not breaking the old code. So what I have learned, it's and fall in love with its deprecated annotation. So let's say we have an old important method function, and we need to update that in like Kotlin, or we need to do some updates by like business logic, anything. So, and it's update important function. So what we can do is use as this deprecated annotation. But if you have work on Java, you know that if we say deprecated, it's going to be there for Java, and it's not going to any changes. You can just Android Studio will just not throw an error, and developers will know that this is deprecated method, and they better use like updated import method. But in Kotlin, there is a great difference. So if we write in this particular case, we can really replace the old important method with updated important method. And everywhere in your IDE, you'll be able to see this hint, like, would you like to replace? So if you have this method like in 100 kind of classes and used in 1,000 times, it's going to be just used with return kind of, or alt enter shortcuts, and it's going to be just fixed. So please, if you are in this kind of stage with your project, just take a note with deprecate annotation. Second thing is if to remove if else to when. So maybe this seems easy, looks like obvious for the first time, but for me it was like update, like when I was just recently checking up the old code, and I realized that just converting from Java and to Kotlin, and we miss this kind of things. So please take a note and check what we can do. And in Kotlin, it can look like this. Yeah, it's much easier, and no need to keep creating this if else braces, brackets, and other than that. Then another tips I would like to share with you. Let's say we have a like old data class, which is like messages delivered, but we are working on updates daily, like every sprints we are updating, and there is a one requirement from a product owner, and he wants to make sure that the message is delivered and is read. And maybe later he has some great idea, and because if message is sent, we will be receiving notification, and is the notification is seen or not. Yeah. So if we keep updating that, like we have to like, it looks that we are going to keep adding all these parameters for all these data classes, but there are another great option. What we can do is create enum and just in message data class use only one parameter, and keep like using all the thing. If there are any other like business logic changes, it's not going to affect at all. So, and what I really love about Kotlin, and I realized like 1 year back, maybe, extension functions. It is the functions that we can we can do some updates in the function without extending the class. For example, here, like an example, we are dividing on a half the heights and the width of the like canvas center, and when we call in function, it's just we are just calling this updates, and it's not going to be anything like every time we are calling it and we're doing changing or we're writing overrides. Yeah. So now it looks pretty easy, and sometimes it's very handy. So, but there is some changes can happen, which is like you found a new feature in Kotlin, and this frequently happens with me. So I start to use this feature everywhere where I can. For example, this is an example. So we have a string, we have a user class, and we're trying to change the username. So we are trying to get this username every time when we call this user. But why we are saying this is bad? Because we are trying to make the user's full name to string, and every time when we call a string to full name, we're going to call username, which is not strings native any functions. So it's like user class is different. We have created a different data class, so there is no need to create that. But how we can use in proper way all these extensions is, for example, we have our string objects to char array function. So we call it, but we would like to do some changes. For example, at I for in front of each item, or we would like to do some another changes. For example, C, instead of C, we would like to put always A. And when we call this to char array method, it's going to be like your changes. Another extension function where we can use it, for example, if we are we have this kind of method where we are calling our classes function, and inside of it, we are checking another enum if this is child protection or not. And to make it look much easier, we can literally divide these two methods into different. We can create another help use like class helpers where we can divide this when kind of condition for two different kind of method. So it's not going to be like hard readable code. It's going to be much easier to read. And if you would like to do any like business logic in the future, so you're not going to change everything in here. So you're going to change only here, and it will look easy, and it's going to be testable. There will be no headache, and you will thank yourself. So another part of using extension functions is with the collections. This is an example how we have created mutable list of strings, and we have added like 3 countries. So how we can create this, like take if we use this take if. This is already native extension functions, which means like as here else also. Sometimes we have run here and the let, and here is take if. All of these are extension functions. So if we think about here, so when we go through the list of countries, and when we see Vietnam, we are going to show it output Vietnam. There is another extension, native extension functions, which is take unless. It means like when we are going to through all this list. Otherwise, if we see Vietnam, we are not showing it, but other countries, yeah, we are showing. Another extension function is infix and extension functions. This is an example where, like, when we use this, we are not going to have any. When we call this function, we are not going to use any curly braces or just normal braces. We just call it, and we can just straight away to work. But sometimes it's going to be difficult to read if you're working in a bigger teams, I guess. But for logical parts, like when you're doing some calculations, I think it's pretty good to use. Yep, this is my short brief of my learnings from the last 1.5 years about Kotlin refactoring. Thank you for your time. If you have any questions, would be glad to answer.
So, folks, if you have any questions, feel free to write them. And Kayla, thank you so much for coming with this talk. I think it's very interesting also to get talks that are based on personal experience, right? Like things like refactoring on Kotlin. Maybe there is like no Coursera course or any tutorial that you can take. So it's based on your real world experience on an app doing refactoring, failing, learning. So let me see if anybody asks Yeah, Huyen loves Infix functions. Maybe one question: do you have any tool that you like to use of course, next to Android Studio? Is there any tool that you like to verify that your refactoring is working, or anything special that you use?
Unfortunately, now I know there is great plugins for refactoring, but I'm using just shortcuts of Android Studio and renaming. Yeah, I think I need to research and to make another topic for that.
Oh, that would be fantastic, certainly. Session on shortcuts that can make your life easier. Yeah, another comment from Huyen: deprecated and replaced with. Yeah, it's certainly very, very useful, right? And it integrates very well with the code. It's not the Javadoc. Like in Javadoc, you could write like a comment, why is it deprecated, etc. This is more programmatic. And any more questions, folks? Well, again, Kayla, thank you so much for being with us. How can people reach out to you if they want to ask you anything and get in touch with you?
This is my Twitter and my LinkedIn. Please feel free to reach out to me anytime. And Enrique, thank you for this opportunity and organizing all these great events. Enjoyed the first speaker's presentation and talking to you as well. Thank you.
It's always a pleasure, Kayla. Thank you so much. And again, if anybody is searching for a new position, Zuhlke is hiring in Ho Chi Minh. So feel free to reach out.
Yes, thank you.
Great. So yeah, here we are. Well, just wanted to thank you both for putting the time, the effort, and staying until esoteric, or waking up very early, or staying until late. Yeah, we'd love to have you. So we hope to welcome you in Saigon at some point in the future. Who knows this year? Who knows, maybe next. And yeah, have a very nice day. And again, thank you for supporting the community in Vietnam.
Yeah, thank you.
Oh, pleasure. Kayla, I really loved your talk. I was like nodding like this the whole time. Like, yes. So I'm sorry. I just had to. I was like, this is kind of silly. I'm backstage, but I had to comment just because I really enjoyed it. I've run across so many things, but yeah, great talk too. So nice to meet you.
Likewise to you. Thank you. Have a good day, evening, Vietnam.
Bye bye.